Hey everybody, so now that we've had an introduction to the matrix and what a matrix is, let's look at how to create one and how to fill it. And there's a really, really interesting, powerful object that I'll introduce you to right now that has so many features for filling up matrices with information that we can use for color, we can use for position, we can use for scale, we can use for rotation, we can use for really just such a wide variety of things. And that is jit.bfg. Jit.bfg creates a matrix and fills it. Now, this also brings us to needing to learn how to express a matrix. A matrix is expressed in terms of the number of planes that it has. For instance, red, green, blue, that would be 3 planes. Or X, Y, Z, that would be 3 planes. The type of data that's stored in each cell. And then the dimensions of the matrix itself, the resolution, if you will. So first we specify the number of planes, 3. And that's going to be very common. There are lots of reasons to have matrices with more than 3 planes, but most of the time we're going to be working with 3-plane matrices in this class. Our type in this class is always going to be float 32, no space, meaning our matrices are filled with 32-bit floating point numbers. You can look that up if you want. Just Google 32-bit floating point number if you're interested. You don't really need to know the technical details of it for this class. It's just a number that has a decimal component, like 1.257. That's a floating point number, and we're using specifically 32-bit floating point numbers, so float 32, no space. And a very common error is for people to put that space in there. That will mess up your matrix. Don't do it. Just remember float 32, no space, and then some dimension. Let's say 128 by 128 cells. So now, this jit.bfg, when it receives a bang, will create a jit.matrix with 3 planes, 128 by 128 cells, with float 32 type data in each cell. And this jit.matrix will just store that matrix and pass it along. And we can in fact send it right to a jit.p window to display its contents. And because it's a 3-plane matrix, it will be displayed as red, green, blue information. And if we want to see this pixel by pixel, we can simply send the size message to our jit.p window. That will make it 128 by 128 pixels. Once we've done that, don't need that size message anymore. And the output of our jit.bfg will go into the jit.matrix. But the jit.bfg needs a basis. It needs a mathematical basis to generate controlled randomness or noise. That's what the jit.bfg does, among other things. It has a number of algorithms for controlled randomness, and controlled randomness is really, really powerful for generating images, patterns, movement, shapes in the computer. And it's really a key to modern multimedia is this notion of generativity. The fact that the computer is going to generate, based on parameters we give it, some changing but coherent pattern over time. This is how we create stars and planets and clouds and pebbles on a beach and anything, really. Anything that exists in multiples in space. Buildings in a city, which is exactly what we're going to be using it for in the final project in this class. In a city with tens of thousands or hundreds of thousands of buildings, nobody is placing each individual building and each individual window by hand. They're using a generative process. And certainly if you're putting pebbles on a beach, you're not hand coloring and placing each pebble using a generative process. So let's look at some of the basis that we have. We can make an attribute change it to basis, and this will show all of the bases that the jit.bfg has. This is the section that we're interested in, the noise basis. And let's just start with cell noise. And now, when we click, we get some sort of image here. And it's not a very interesting image. What is this cell noise? Well, cell noise is basically static. It's basically random values assigned to pixels. That's not what this looks like at the moment. That's because jit.bfg has a lot of settings that we can modify. So let's make some space here. And let's change the scale. And now scale with the jit.bfg is unfortunately set up in a way that it's hard to manipulate from an attribute. We can type it in, and that will change it, but it's not easy to be dynamic. So I'm going to show you a new structure, a new object in Max called pack. That's going to allow us to take two numbers and combine them into a list. There's two different versions of pack. One is PACK and one is PAK. We're going to use the PAK version. And we're going to pack together two floating point numbers. So we say pack space F space F. Pack together two floating point numbers into a list. And then we'll use the F key to create two floating point number boxes. We're going to send this packed list into scale. And now we can control the first two values in scale independently and easily with scrolling. Let's make these number boxes a little wider so we can get finer grained control. But notice that nothing is happening down here in our matrix that's output from our jit.bfg, because BFG requires us to send a bang to the jit.bfg to render it each time we want a new frame. And so one of the things we could do is we could just take this pack, hook it up to the button, and there we go. Every time we change the value, we get new output. And that's a perfectly valid way to do it. And actually, it's a very economical way to do it, meaning that we're not going to render the jit.bfg any more often than we need to. However, for our purposes right now, just for quick feedback on what we're doing, we're going to render our jit.bfg every single frame. And there's a very easy way to do that, which is attached to our jit.world. I'm going to make a jit.world, but I'm going to make it visible 0. I don't actually need to see it right now. At visible 0, at enable 1. And the reason why I'm making this is because the middle outlet of jit.world sends a bang every frame. So if I put a jit.fps GUI, like we looked at in the last tutorial, I can see, aha, now I have a certain number of frames per second. My computer is rendering around 50 frames per second, but it's going up and down, probably because I'm screen capturing, I'm recording, and so the computer's got to do some work in order to keep recording my voice in this image. So that's fine. I will just take this render bang and have it render my jit.bfg every single frame. And so now when I make an adjustment, you can see I have real-time feedback. So again, what is this? What's actually happening here? Well, what's happening is a random pattern is being generated, but it's a predictable random pattern made up of gray squares. And you can see they're not perfectly gray squares. If we using scale, if we zoom in on this, we can see that there's some color aberrations around the edges. And that is because there's 3 planes being generated, a red plane, a green plane, and a blue plane, and they're by default out of alignment. So we take another attribute here, and we take a look at the alignment. They're out of alignment by a factor of 10. What does that mean? Well, that just means the red, green, and blue are offset from each other. So if we change the alignment to 0, now red, green, and blue are in perfect alignment, and all of our squares are gray. And as I increase the alignment, the red, green, and blue squares slide away from each other, giving me a more and more complex pattern. And this, of course, interacts with scale. So already I have quite an interesting and expressive range of different colors I can get out of this cell noise. And values that are close to 0 are going to be close to gray with some color aberrations. And values that are further are going to be more brightly colored and randomly colored. But of course, it also is a bit of a monotonous randomness in that it's sort of all extremely bright and proportionate with all different colors. So I also can give each plane of my matrix a weight. Choosing weight from the attribute. And again, here I have one of those attribute that's hard to interact with, so I'm going to use a pack. And in this case, because I have 3 planes, I'm going to use a pack FFF, F space F space F, so that I can pack 3 floating point numbers together. 1, 2, and 3. And of course, the default weight is 111. But if I want to alter it, I can, for instance, reduce the blueness. And now I'm going to get more oranges, yellows, reds, and greens. I can reduce the blue and the green, so I get a redder pattern. I can totally get rid of green and add blue back in, so I get reds and purples. This gets complicated and messy pretty quickly, so we want to do some housekeeping here. The first thing we want to do is, and you can say I already started to do this by creating this floating point number box here, is not use the attribute, but as we've seen in other tutorials, place the number boxes over the attribute so that we're interacting not with the attribute itself, but with a group of number boxes sitting on top of the attribute. And then holding down the Option key, clicking and dragging, we can highlight the patch cords and the boxes and use Command K to hide on lock, and immediately things are a lot clearer. And also, we're going to want to add a preset so that we can begin to store settings that we like. I like a larger bubble size on my preset so the buttons are a little bit easier. And also you want to pick a sensible number per row. If you pick 5 per row, it's pretty easy to keep track of. But if you pick like 7 per row, then it's weird. You don't know, this is 1, 8. What's that one? 15? 16. But if you pick 5 per row, then it's pretty easy to keep track of. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, etc. And then you have to connect the left inlet to every message box you want to save. and then you can Option click and drag if you like, and Command K so that those are hidden on lock, and you get a very clean control panel. Now, of course, we can't save an attribute with a preset, so we're going to need to save our basis in another way. And I have in the comment section and also on the Blackboard site that you can use to select some noise. You use the middle outlet of the U menu into the attribute for basis, and then you can choose different noise types, and that can be saved into your preset, like so. And again, Option click and drag, Command K to hide on lock, and you can hide anything you don't want to see on lock, Command K, and then you have a much cleaner interface, and it's all savable. So we'll go back to our noise cell. Find a pattern and an arrangement that we like. And shift click in our preset to save it, and we can choose some other arrangement. And shift click to save that, and then easily switch back and forth between these generated images. And what can we use these generated images for? Well, they immediately become procedurally generated textures that we could put directly into a jit.gl.material, for instance. And now we can make our jit.world visible. And we can see that our object is textured. By the generative noise. And because it's generated in real time, it can, of course, be animated. So now I have the possibility of moving images on my objects in three-dimensional space, which is a really nice step forward. And if you want something that's continuously moving, a very nice way to do it is with the offset. And with offset, we again need a pack for both the X and the Y dimension. Option click and drag that. Send the pack into the offset. An offset typically you're not going to want to save into your preset. You can, but your offset is usually used for creating a flow or a movement, a moving pattern. And as such, you wouldn't so much save it into your preset as you would drive it. Now, how could you drive it? Well, there's a lot of different ways, as is always the case in Macs. Let's just take a look at one quick way to do that. We can drive the offset using a metronome, which we create using the metro object. And I'll just create a metronome that ticks 24 times a second. So I say metro at interval 24 space hz, 24 hertz. Hertz is the measurement for times per second. So 1 hertz is once per second. 2 hertz is twice per second. 24 hertz is 24 times per second. Because 24 is a pretty standard frame rate for film and video. So that's the reason I picked it, 24 hertz. And we use a toggle created with the letter T, to turn our metronome on and off. And our metronome just sends a bang 24 times a second. And that's useful for a lot of different things. What we're going to use it for is just to increment a value. So we'll use an object called accum, which is an accumulator. Give it the argument of 0 point, letting us know it's going to be a floating point accumulator, and we'll accumulate by 0.01 per frame. And so this is a very common structure that we'll use a lot. We have a metronome going at a certain interval. The metronome is feeding a value into the second inlet of accumulator, which, as we can see, adds that input to the current value stored in the accumulator. And then when the left inlet receives a bang, it outputs a value. So if we put a float down here, you see we have a increasing value that will stop when I turn the metronome off, start up again when I turn the metronome on, and if I want to, I can multiply the current value by some other value, like 0, and this will cause my accumulator to reset. And so if I plug this into my offset, now I've got a dynamically changing pattern that's crawling across the surface of my object. And that's pretty neat. And this toggle can be turned on, and I'll give you a new object to turn it on. Instead of load bang, we're going to use load mess, and that loads a message instead of just a bang, and we're going to load the message 1, because 1 will always turn on a toggle. So load mess 1, it's very similar to load bang, except it ensures that the toggle goes on when the patcher loads. So let's take a look at some other basis functions on the jit.bfg. So we look at cell noise, and we can see just this one simple basis can generate, widely divergent patterns. Turn this off for the moment. And these are just a few of the patterns it can make. You can work with these controls to get a really wide variety of different things. The next one we'll look at is checker noise. And checker noise is, as you might expect, just a checkerboard. So why is it called noise? Well, it's not really noise in that it's not really random, but when we start to shift the alignment, we can get some really interesting patterns from it. And then by adjusting the weight, we can get different color profiles out of it. And of course, animate it using the offset. So, not really noise, but certainly useful. Of course, it can be scaled differently along different dimensions. So you can get something like this. So it's not random, but it gives a sense of randomness. And of course, if we offset it on both dimensions, it'll have a different quality of motion as well. So I'll use the same metronome to move it on the X and the Y at different rates. And I can get quite an interesting progression. One of the things that you can do is you can include the toggle into your preset. So for instance, whether or not a pattern is going to have motion, and in this case we could actually create two metros here, give each dimension its own metronome. Save those into the pattern so that if we want this checkerboard to be a still pattern, we save it as a still pattern. If we want this to be a still pattern, save it as a still pattern. If we want this to be a moving pattern, save it as a moving pattern. Moving pattern, still pattern, still pattern. Moving pattern along one dimension, still pattern. And I'm shift clicking to save. So the motion is saved into the preset because the toggles have been connected to the left inlet of the preset. One other feature of the checkerboard noise that only applies to the checkerboard noise is the smoothing feature. And when a feature is only applicable to a particular basis, we can't unfortunately access it with an attrui. So let's first of all see what it is. The full message is setAttr, meaning set attribute, basis, meaning set an attribute of this basis, smooth, and then some value. So setAttr basis smooth 0.5, and we can see it blurs the edges of the squares. There's 0.25, 0.125 just gives us a little bit of blurring on the edges, but that's quite useful. How do we access this in a less cumbersome way? Well, there's a great message called prepend. So instead of typing this into a message box, we can type it into the prepend object. And say prepend setAttr basis. And that will automatically put those symbols, setAttr basis, in front of whatever we send it. And we can also say prepend smooth. And now we can just use a floating point number box and dynamically change the smoothness of the edges of our checker. And if we like that, we can include that in the preset and shift click to save it. And then if we don't want it, for instance here, we shift click to save without it. And shift click to save without it there. So this one has smoothing on the edges. Actually, I really like the look of the smoothing on the edges with this one. It's quite nice. Gives it like a gradient effect. So I'm going to add it here and actually make it very subtle on this one. So now I have 5 different patterns. I have these two noise.cell patterns. I have these noise.checker patterns. And let's take a look at Simplex Noise. Simplex Noise is very useful. Simplex Noise is your rocks, your clouds. There's a lot of different sort of natural and fantasy phenomena that you can generate with simplex noise. And the weight function functions a little bit differently with simplex noise, which to really, really nice effect, actually. You can get some great looking stuff from out of your simplex noise by adjusting the weight. And of course it animates with the offset. And if we adjust the alignment, we'll get color variations as well. Let's set the weights all back to 1 so we can see what those color variations look like. And of course, the scale lets us zoom way in or way out, or any combination. So it's really easy to find nice, compelling patterns using these tools. And smooth doesn't do anything with simplex noise. That's important. Smooth is only appropriate to checker. So simplex with an alignment of 1 is really good for clouds, particularly like spooky clouds. And of course, your weight can be adjusted for overall brightness just by changing all 3 values at the same time. And scale can be changed at the same time, also using the same technique. What's very important, though, is that you don't, if you're using a single number box to control both or all 3 of something, you definitely don't want to connect that number box to your preset, because that will conflict with the 2 that you have connected already. So if you like this, you can save it and you'll be able to recall it, in part because you didn't connect these 2 number boxes. If you connect these 2 number boxes, they will, when they're restored, overwrite the other recalled values that are in here. So for instance, if we wanted a non-symmetrical scale, something like that kind of like brushed metal look, and we save that here and switch back and forth between these 2, if we had connected these number boxes to the preset, we wouldn't be able to have one where this X and Y scales are different. So there's a lot more patterns, and I'm only going to go into 1 more right now, and we'll cover the others in another tutorial. Gradient noise, also good for clouds, like a softer cloud, and good for lots of subtle patterning. It's similar to the simplex noise, but it's a lot softer. It's quite smoothed. And it has the additional feature of being able to be filtered. So here I can say prepend filter. and I'm hooking it to the same prepend set adder basis, because I don't need to retype that. I can use the same prepend set adder basis. And filter is an attribute only of this basis, only of this noise gradient. Well, actually, only of the ones we've looked at so far, only of this noise gradient. And I have another saved U menu that will allow you to access a series of filters that can be applied to this noise by using the middle outlet into the prepend filter message. And the default, the one that we see operating when we switch to noise gradient, is the transfer smooth step. That's the smoothing filter that's applied. But take a look at some of the others that are available. Transfer step gives us this really nice combination of smooth noise with a checkerboard pattern. Some of them are quite subtle. But some of them are quite dramatic, like transfer pulse, transfer smooth pulse, transfer sine, which I think is a quite beautiful variation. It looks quite interesting if one changes the alignment as well. Interacts nicely with the offsets to create some really unusual looks. And transfer linear. So really play around with these few that we've looked at. As I say, we'll look at more of them in another video. And see if you can come up with a library of patterns that interest you. And as one further thing that can be saved in your preset, actually, the speed here of the transition can be saved. We're using a message box. If we were to use a number box here, instead of a message box, I'll just remove these reset buttons, make these a bit larger, and include them also in the preset. Then the speed could be stored so that there was a different speed with each pattern. So you can see the preset is a very, very powerful tool for saving lots of different information in your patch. But it's important to note that anytime you add something new, you have to go back through your presets, and if it's relevant, you need to add it to the preset. For instance, it's not relevant here because this metro isn't even on, but it is relevant here because this metro is on. It's also relevant here. So we want it to be set to the correct value so that we achieve the effect that we want. Once you're done with a patch like this, it's really important that you tidy up, that you arrange things the way that you want them, that you hide patch cords that don't need to be seen. And once the patch cords are hidden, now we may need to move these things around so that we know what they're doing. I could, for instance, put this over here to the left, maybe. And again, this goes back to this notion of control panel building. Like, how do we want this to look? Another thing that's useful when you're starting to work with a lot of preset stuff like this is to take stock and say, hey, rather than including all this stuff in a preset, it might be better to exclude things from the preset. You can just remove all the cables. And this will not affect the information you've already saved. And instead of specifically including things that you want to save with your preset, you can use the third outlet of preset to connect it to things you explicitly don't want to save with your preset. And right now, we have this and this, which we've decided we don't want to save with the preset. And when I'm doing that, I like to option click and drag and then right click and color those chords just to make it clear that they are exclusion chords, just so I don't lose track of what I'm doing. And I can also Command K them so they're hidden on lock. Now, the problem is it's easy to miss boxes that shouldn't be saved. Take a look at this patch and see if you can see any that should not be saved. If you noticed these two number boxes and think, maybe those shouldn't be saved in the preset, you're right. They will create a jump or a discontinuity if they are saved and recalled. So we're going to remove those. Click, hold down Shift, drag, and delete them. Because we don't really need them, we're seeing the very same values here. And since we're seeing the same values here, we actually should specifically exclude these two as well. So that they are not saved with the preset. And if you want to be even clearer about what's not saved, you can select the ones that aren't saved and actually change the color of the background of the number box itself. So now it's clear that everything that's not in red is saved. Only these connected with the red patch cords are excluded from the preset. And of course, you can go very far in organizing and cleaning up your patches. You don't have to go crazy, but make it organized, make it readable, make it so it makes sense to you. And a lot of times when using Macs professionally, what you're doing is designing control panels for other people to use in a performance setting or a studio setting. So a lot of thought can go into how these control panels are designed.